Okay, the first podcast is on the chapter 1, and it deals with rise over run, or the concept of slope. So just a couple quick definitions. The slope is really just a measure of the steepness of how something is slanted. So when we're talking about the slope of an object, we're really just looking at the steepness of that slant. So for example, an application for this could be something as simple as, say, a roof of a house, and the steepness of that slope right there would determine, or could be determined and calculated mathematically, and we may want it to be a steeper slant depending on certain factors like snow removal or other things like that. So slope can actually be calculated using the following relationship or formula. So the slope of a slant is equal to the change in vertical distance divided by the change in horizontal distance. Now notice that in this formula, I've used this letter right here, or this, well, it is a letter. It's the Greek letter, delta. And delta is really just a symbol that represents change in some sort of a value. So what do I mean by the change in vertical distance over the change in horizontal distance? Well, if we go back to our house here and we take a look at this roof that we've built, and we want to calculate the slope of the roof, we can do that by creating a right angle triangle on that roof, and we can measure the change in the vertical distance, so that value right there, over the change in the horizontal distance, which is this value right here. And so by taking a comparison of those two and dividing one over the other, we get this value right here, which is our slope. Okay, now mathematically we can express this using the following formula. So little m, which will stand for slope, is equal to the rise, or the change in vertical distance, over the run, or the change in horizontal distance. Okay, and in this application, we can use this very simple formula to calculate slopes of slanted objects. Okay, so now let's look at a couple examples that would use slope. And so these ones are right out of the textbook, and the solutions are there, but we're going to go through them together. So Charlene is working on a project. She wants to make a brass cookbook holder. She doesn't have a protractor to measure this angle, so she wouldn't know what this angle was in order to actually make this slanted cookbook holder, and she wants to make it exactly like the drawing. She does, however, have graph paper, and so from this, we're going to calculate the slope of the cookbook holder and then a number of other things. So whenever I am going to do a mathematical problem involving a formula, what I like to do first of all is I like to identify what my variables are. And so what do I mean by that? Well, it means that if I'm looking at the formula for slope, the first thing to do is to write down what the formula is. Now I can go back and I can calculate it. And notice I put a couple lines in here just to make things easy. Well, if I want to count this, and there are no units there, so we're just going to count the boxes. The rise, remember, is the change in vertical distance. So that's this one right here. And so by counting the boxes, 1, 2, 3, 4, 5, 6, this cookbook holder seems to rise up 6 units. So my slope, my first variable, is going to be equal to 6, because that's my rise, or my change in vertical. My run is my horizontal. So again, I'm going to do the same thing, and I'll use a different color for this. And so I'm going to count my horizontals. And I've got 4 horizontal boxes. So my slope is going to be equal to, or sorry, my run will be equal to 4. So my slope is in fact 6 over 4. Now, as a fraction, this can be simplified, right? Because both values can be divided by 2. So when I simplify this fraction, I get 3 over 2. And that's my slope represented as a fraction. Now, if we go to part B, what does this answer tell us about the relationship between vertical change and horizontal change of the cookbook? Well, it tells us that for every 3 places we go up, our run is 2. So in other words, for every 2 units changed horizontally, our change vertically is 3. And so that gives us a way, if we wanted to actually build this cookbook holder, we know what we would have to do. We would have to create a cookbook holder so that we're changing, for every 2 horizontally, we're changing 3 vertically, or 4, 6, right? Which is the same thing. And that goes to question, or part C. So Andy says the slope is 3 over 2, which we've calculated it to be 3 over 2. Amanda will actually take her calculator, and so if you divide 3 divided by 2, you're going to find that that answer would be 1.5. So Amanda says that that's 1.5. Jennifer says the slope is 6 to 4. Now 6 to 4 is a ratio. And really all a ratio is just another way to write a fraction. So 6 to 4 as a ratio, right, can be expressed as a fraction as 6 over 4, which we've already done as part of our slope, which would be reduced down to 3 over 2. Okay, so in all 3 cases, the 3 people are actually all right. They're just different variations and different ways that we can express that number. We can either do it as a decimal by taking 3 divided by 2. We can do it as a fraction by leaving it as 3 over 2, or we could do it as a ratio, and a ratio being 6 to 4. And all 3 of those mean the same thing in terms of the slope of this cookbook holder. Okay, so let's look at one more example, and then we'll get on to some problems. So in this example, Duncan and Casey are using hand trucks to move small boxes from a house to a garage. They lay a loading ramp against the house steps, which are 18 inches high. The slope of the ramp is 0.2. What is the horizontal run distance in feet from the base of the ramp to point X? Okay, well let's begin to tackle this problem by asking ourselves what we're given. Now, oftentimes, this goes back to my grade 11 physics teacher. He always said that when doing a word problem, and that's exactly what this is, it's a word problem, draw a picture. And so what I've done here, and your book does a good job of it too, is they've drawn a picture. Now we're going to plug in some values that were given. So we know that the slope, right, remember that's the steepness, that's this value right here is 0.2. Right, that tells us how steep that slope is. I know that the stairs are 18 inches high. Okay, so this value right here is 18 inches. And I want to find from here all the way to X. So in other words, I'm looking for the run. Okay, and I'm given my rise and I'm given my slope. Now in this case, the first thing that I always do is I rewrite the formula, right? And then that way you know what to deal with. Okay, so slope is equal to rise over run. Now what I do is I plug in what I'm given. So I'm given the slope. So my slope is 0.2. I'm given the rise. The rise is 18 inches. And I'm not given the run. Now there's 2 ways that we can do this, and I'm going to show you both. The first way is that I can simply put run there. Okay, and then I can do some math to try to solve it, right? Now, the other way to do it, and the way that I find it a little bit more easier, I've got my formula here. I'm going to substitute the word run for x, because that's what I need to find, right? And now this sets up algebra. It sets up something that I need to do algebraically in order to solve this value. Okay, now, in order to solve for x, what I need to do is I need to get x by itself. Now, x is here, right? It's in the denominator. X can't be in the denominator, so I need to move x up. The only way to do that is to times this side by x and to times this side by x. So I've done that. I've canceled these x's out. Now, the step that most people do not do is you rewrite the expression. Okay, now I still need to solve for x. So 0.2 times something is going to give me 18 inches. Well, to figure that out, I do the opposite. So I go 0.2 divided by 0.2, and I do the same thing on this side, 0.2. Right? So my x is going to be equal to 18 divided by 0.2. And when we calculate that out, we get 90 inches. Now, 90 inches is still not what we're asked to find because we want to know the feet. And so remember that there are 12 inches in every foot. So I need to take this value here and I need to divide it by 12. So 90 inches divided by 12 is going to be equal to 7.5 feet. And so that's this value here. Now, as a check, we can always go back and do rise over run. So if 18 inches, and remember we would have to take this value and express it as feet, or we could just take our 90, which we've already calculated. If 18 divided by 90 gives me 0.2, then I've done everything right. Okay, now the final thing to do in math, and this is just to help me when it comes to marking for midterms or finals or even assignments, is just to put a nice box around your answer, and then that way I know that that's your answer. So that's the first podcast on slope, and hope you've enjoyed it.